Hi guys, today we'll be discussing time value of money. After listening to this discussion, you will be able to understand the concept of time value of money. You will be able to understand what do we mean by interest. You will be able to differentiate between simple and compound interest. You will be able to understand what do we mean by annuities, how ordinary annuities differ from annuity dues, how can we apply annuities in real world products, and at the end of the chapter you will be able to understand amortization of loans. The areas we'll be covering in this chapter are simple interest, compound interest, and amortization of loans and annuities. What would you prefer? A $5,000 today or $5,000 after 5 years? If you prefer the one today, congratulations, you have realized time value of money and you can understand it. Why time is such an important factor in your financial decisions? Because time enables you to delay your consumptions, and at the same time you have opportunities to invest those amounts somewhere and earn return. That's why time is such an important factor in your financial decisions. What is interest? Incremental or additional amount calculated on the basis of the principal amount is a result of lending or borrowing money. Interest is of two types: simple interest and compound interest. Interest paid or received on the principal amount is called simple interest, while compound interest is interest paid or received on the previously earned interest as well as on the principal amount. This is called compound interest. So the difference between simple and compound interest is that of interest on the previously earned interest. If your investment period is a single year, the simple interest and compound interest will result in the same amount. How can we calculate simple interest? The formula for that is simple interest is equal to P naught IN, where P naught is the principal amount borrowed or lended, I is the interest rate, and N is the number of periods. So simple interest is equal to PIN. Assume that you have deposited $1,000 in an account earning 7% simple interest for 2 years. What is the accumulated interest at the end of the second year? As we said, simple interest is equal to PIN. P naught in this case is principal amount is 1000, interest rate is 0.07, and the number of periods is 2. While multiplying all these, the interest is equal to $140. This is simple interest for 2 years. Then we have another concept of future value of a deposit. Future value is the value at some future time of a present amount of money or a series of payments evaluated at a given interest rate. Future value can be calculated with the help of formula principal amount plus simple interest. In our previously discussed example, 1000 was the principal amount and $140 was the simple interest. That's why combining these two means 1140 is the future value of $1,000 today at a rate of 7% interest. Then we have present value concept. What is the present value of the previous problem? The present value is simply $1,000 what you have originally deposited in your account. So we can define present value is the current value of a future amount of money or a series of payments evaluated at a given interest rate. Assume that you have deposited $1,000 at a compound interest of 7%. Now we'll be discussing compound interest rate for 2 years. So we have to draw a timeline, that is 0 means today, 1 means a year after today, and 2 means 2 years after today. You have deposited $1,000 at a rate of 7%, but remember you have to apply compound interest rate. Then what would be the future value of this amount after 2 years? Means what will be your account balance after 2 years? Future value formula is this one. Future value is equal to P naught into 1 plus I whole to the power n. Here, if this is the single period case, then 1000 multiplied by 1.07, so 1070, which was also the case in the case of simple interest. So if the investment period is a single one, simple interest and compound interest will result the same future value. But if the investment period is 2, we said that f(v) is equal to p naught into 1 plus I whole to the power n. Here n will be equal to 2. This is resulted in such a way, future value into 1 plus I, this amount will result a future value at the end of year number 2, where FV1 was future value at the end of year number 1. So we have further multiplied it by a factor 1 plus I whole to the power 1. So this will be the same amount as P naught is equal to 1 into 1 plus I into 1 plus I for each year, or P naught into 1 plus I whole to the power 2, where 2 represents 2 years from today. By putting values in this amount, we will get 1144.90. If you recall your previous slide, 2 years case, this amount of future value was 1,140 US dollars. Here we have $4.9 extra. This is actually interest on the previously earned interest. So future value formula in the case of compound interest is this one. FVN is equal to P naught into 1 plus I whole to the power n, where FVN is future value after n years, P naught is the principal amount you are going to deposit or borrow, and I is the interest rate, while n is the number of periods. Or we can calculate this value with the help of ready-made tables available at the appendix of your book also. With the help of that table, you can also use this formula, principal amount multiplied by a factor. This factor can be found in appendix table number 1. This is equal to principal amount multiplied by future value interest factor for I interest rate in number of years. In appendix table, you can find each row represents number of years. For example, second row in this table represents investments for 2 years periods, while each column represents specific interest rate. Here in this case, we were having 2 years, 2 periods and 7% interest rate. That's why by following line number 2 and this 7% column, we found that future value interest factor is 1.145. If you multiply this factor with the principal amount, you will get amount of 1145. This 45 is due to rounding of data. So this is actually future value after 2 years at a compound interest rate of 7%. Here we have an example. Julie Miller wants to know how large her deposit of 10,000 today will become at a compound annual interest rate of 10% for 5 years. So she has deposited 10,000 in her account at a rate of 10% and want to know her account balance after the year number 5. That's why she wanna know FV5. So FV5 can be calculated with the help of this formula. 10,000 is the principal amount, 1 plus I is 10%, that is 0.10 whole to the power 5. By putting the values and multiplying it, we get 16,105. She is expected to have this balance in her account at the end of 5 years. We can solve this problem with the help of table number 1 also. That is principal amount multiplied by future value interest factor at the rate of 10% for 5 years. If we get this factor from the table, 10% column in 5th number row, this will be equal to 1.611. So 16,110, almost the same amount as we do with the help of calculations. There is also a rough case. How much time is needed for your investment to get it double? We in finance call it rule of 72. Rule of 72 tells you how long does it take to double 5,000 US dollars at a compound rate of 12%, say. So rule of 72 means 72 divided by interest rate. Here in this case, we are having 12% rate. That's why 72 divided by 0.12 means 6 years. So if the interest rate is 12%, in 6 years, you can almost double your investment amount. Assume that you need 10,000 in 2 years. Let's examine the process to determine how much you need to deposit today at a discount rate of 7% compounded annually. Here we have the opposite way. You are given a future value after year number 2, that is 1,000 in this case, and you are asked to calculate the present worth of this amount today. So that is called present value. If the interest rate or discount rate is 7%, so you have to discount it by 7%. Present value formula is equal to future value divided by 1 plus I whole to the power n. Here in this case, we have n is equal to 2. That's why FV2 divided by 1 plus I whole to the power square. Putting values in this, we will get 873.44. Means that if it is discounted by at the rate of 7%, she needs to deposit 873.44 today in her account. Compounding it at the rate of 7% per 2 years will make its future value 1,000. We can solve this problem also with the help of table number 2. In factor can be found in table number 2 for n periods in I% interest rate. Here in this case, we have 7% interest rate for 2 years. That's why we will look in 7% column, while in row number 2 representing 2 periods. And we can find that the present value interest factor is 0.873 in this case. Here we have an example. Julie Miller wants to know how large a deposit to make so that the money will grow to 10,000 US dollars in 5 years at a discount rate of 10%. So we have to calculate its value. Here present value is equal to future value divided by 1 plus I whole to the power n. Future value in this case is desired is 10,000. That's why it is divided by 1 plus 0.10 whole to the power 5. While calculating this, we can compute that she needs to deposit 6,209 US dollars today. Thank you.